So firstly, we need to find the probability that when x2 is 1. So according to the problem, we can see that x2 is related to x1, and the probability is based on the previous event probability. So if we need to find the probability that x2 is 1, we need to know the probability that x1 equals to 0 and x1 equals to 1. So according to this problem, we can see that if we need to find this, we need to use the probability that x1 is 0 and also the probability that x1 is 1, and also the probability that when the current x is 1, given that the previous probability is 0, and the previous probability is event is 1. So after that, we can write this formula that put the probability x1 equals to 0 times the probability x2 is 1, given that the x1 is 0, and also the probability x1 is 1 times that the probability that x2 is 1, given that x1 is 1. So after that, we put the data into this formula and finally find that when x2 is 1, the probability of this event is 0.64. And at this problem, we also need to find the probability that x2 is 0, since we might use this for the further question. So similarly, we do the same probability calculation as the probability that the x2 is 1. So it also consists of two parts, which is the probability when x1 is 0 and also the probability x1 is 1, and to calculate the probability that x2 is 0, and the final answer is 0.36. So the second question is to find that x3 is 1. So it's the same as the first question. So if we need to calculate this, we need to find the probability that x2 is 0 and the probability x2 is 1, and also we need to use the given condition to find the answer. So for example, if we need to find the probability that x3 is 0, we need to find that the probability x2 is 0 and times the probability x3 is 1, given that x2 is 0, and also the probability that x2 is 1, given that times the probability that x3 is 1, given that x2 is 0. And also we get this data from the problem and previous question, and then put the data into this formula, and finally find that the probability that when x3 is 0, x3 is 1 is that 0.592. And then we also need to find the probability that x3 is 0. Since they are exclusive neutral, so we can just use 1 minus the probability x3 is 1 and get the answer that 0.408. So the third question is need to find the probability that x1 is 0 given that x3 is 1. So firstly, we simplify this probability. So it will be the probability x1 is 0 and x3 is 1 divide probability x3 is 0. Since and then the probability x1 is 0 and x3 is 1 equals to the probability that x3 is 1 given that x1 is 0 times the probability that x1 is 0 divide the probability that x3 is 1. From the above question, we can get the probability x1 equals to 0 and also the probability that x3 is 1. So what we need to find is that the probability that when x3 is 1 given that x1 is 0. So if we need to find this, we need to calculate the probability x3 is 0 and x3 is 1 in another way. So put this formula, put our data into this formula, and we can find that the probability that when x3 is 1 given that x1 is 0 is that 0.52. So after that, we can get all of the data from this formula, and then we put them into this formula, and finally we get that when the probability that x1 is 0 given that x3 is 1, the answer is that 0.176. So the final question is need to find when n equals to infinity, we need to find the probability that xn is equals to 0. So there are two ways to find this. The first one is that we also need to use the third question formula, and we need to times n times to get the question. So after calculate this, we could get that when n equals to infinity, the probability that xn equals to 0 is 3 divided 7. Or we can suppose that the probability that xn minus 1 equals to 0, the probability is a, and when xn minus 1 equals to 0, the probability is 1 minus a, and also as xn. So since n is equals to infinity, we can just list this formula, and then we can find a equals to 3 divided 7. So we can see that the final answer when n equals to infinity, the probability that xn equals to 0 is 7